So we've seen that E trans is equal to 3/2 nRT, that's E trans, and that's equal to 1/2 nmm VRMS squared. The n's cancel, and as a proportionality relationship, T is proportional to mm VRMS squared, which means that VRMS squared is proportional to T times 1 over mm, and VRMS is proportional to the square root of T times 1 over the square root of mm. Okay. And now we're going to do a problem with that, and we're going to use proportionality. And let's solve a problem of a type that we hitherto involve concepts hitherto you may not have heard of. And I've chosen as a topic effusion. Effusion is the property by which here's a flask and here's a container, and there's gas in the container, but the flask has a stopper, and the stopper is not perfect, and so the gas slowly leaks out. The gas leaks out. And effusion is the rate at which the gas leaks. Effusion will go by the letter E, is equal to the number of molecules escaping divided by the given time. Okay, so now let's use our concept of effusion, use our relationship for VRMS, and let's find out something about it. What are the things that control effusion? Well, we have a gas inside this container, and so let's say it has a certain number of moles. N. What is the proportionality relationship between E and N? If you double the number of molecules in the container, what will happen to the rate of the rate at which molecules escape? Put it in chat. Well, if you double the number of molecules, twice as many will escape. That makes it directly proportional. The bigger and bigger you make the container, the harder and harder it is for the gas molecules to find the stopper. So if I double the volume, what will happen to the number of molecules that escape, the rate of escape? Well, the bigger the volume, the less. If I double the volume, the number of molecules escape is 1/2. That's indirectly proportional. What other factor controls effusion? Put in chat if you can think of a factor that controls. And you can think of the factor I think that is the easiest to think of is VRMS, how fast the molecules are moving, which of course contains the effect of the temperature. So, if they're moving twice as fast, how many times faster do they escape? And the answer is twice as fast, so it's proportional to VRMS. And now we can use the relationship that I have in red and boxed in red above. E is proportional to N times 1 over V times the square root of T times 1 over the square root of the molecular mass.